All right, let's go into our next section of chapter 6. So last time we talked about perpendicular and angle bisectors and a couple theorems that went along with those particular topics or figures. Today we're going to talk about some different types of figures and their relationships within triangles. So now we're going to start kind of figuring out what do these different pieces do within the triangle that we're going to be discussing. So the first thing we'd start with is just a quick vocabulary term, which is concurrent, or this point of concurrency. So that's a term you're going to see used throughout the sections here. And so the definition, when three or more lines, rays, or segments, so as long as we're talking lines or line segments, things like that, whenever they intersect at the same point, those lines are called concurrent. So if we see down in the picture here, we have this line, and this line all intersecting at the same point, point A. So that's what we call concurrent. What that point then that we're talking about here, point A in the middle, is called the point of concurrency. And that's a phrase we're going to see, like I said, used throughout this particular section and into some of the sections later on in the chapter. So point of concurrency, where those three or more lines are all coming together and meeting. So that point of concurrency, what's going to be special about it is we're going to talk about different types. And so the first type that we talk about is called the circumcenter of a triangle. So that's the term right here. So the circumcenter of a triangle. Now what you want to be able to do here is match each center. So we're going to talk about some different centers within the circle. We want to match those centers up with what's creating them. So what type of segments are creating these particular centers. So when we're going through this definition here, we want to really pay close attention to a couple of things. First, in a triangle, the perpendicular bisectors, we talked about those last section. If I have perpendicular bisectors for each side of my triangle, so I've got side AB, I've got side BC, and I've got side AC in the picture below here. The perpendicular bisectors, that's these black lines, and the system I used to create this picture didn't have all the things I needed, so I'm going to add some stuff here. But these black lines, so D out to this side, forms a perpendicular bisector. So I've got it perpendicular to AB, and it cuts AB exactly in half. Then on the other side, BC, I notice that this black line D comes out to BC is a perpendicular bisector. It cuts BC directly in half. And then this last piece, D out to this side AC, is perpendicular, and it cuts side AC in half. So what's happening here is we have three perpendicular bisectors. So I've got 1, 2, 3 perpendicular bisectors. Those three bisectors all came together and met right here. This is one of the centers of our circle, and it's what we call the circumcenter. So what I want you to take away from here is being able to match up. If it's perpendicular bisectors, we created the circumcenter. So perpendicular bisector matches with circumcenter. Now the circumcenter, what's special about it is that it's the same distance to each of the vertices or each of the corners of the triangle. So point D right here in the middle, where all these perpendicular bisectors meet, so we're looking at right there, where all three of those points meet, if I were to travel out to point B, that would be the exact same distance as if I started at D and traveled out to point C. So that those two pieces are identical. And then if I start at D and travel out to point A here, it's also the exact same distance. So if D to A was 5 units long, that means D to B is 5 units long, and D to C is 5 units long. So there's a couple of things that we want to make sure we understand with circumcenter. It's made from perpendicular bisectors, and that circumcenter is going to be the same distance from each of the corners of the triangle. Those are kind of the key pieces we have to remember there. The second type of center that we're going to talk about is called the incenter. Now the incenter is formed from angle bisectors. So incenter, angle bisectors, those are the two pieces I want you to be able to put together. So when we look at the picture down below, again, the system I used didn't have all the things I needed to mark here. So what we're saying is this line in green here from A to D is an angle bisector. It cuts those top angles in half. And then from D out to C over here, it cuts angle C in half, and then D out to B, it cuts that side or that angle in half as well. So I'm going to have three angle bisectors in the picture. So A to D, D to C, D to B. All of those are angle bisectors. What it then creates is another center of my triangle called the incenter. Now, what's special about the incenter is that if I go from the incenter directly out to any one of my sides, so if I come out straight to line segment AC, so if I come out to this outside here, and then if I start at D and I go out to line BC here, and if I start at D and I go out to line AB, so if I go out to any one of my sides, now I'm going to go straight out. So I'm going to go perpendicular to AC, perpendicular to BC, perpendicular to AB. I want to go straight from my point out to the side. When I do that, all three of those distances, so D to the outside of my triangle in either direction, is going to be exactly the same. So if I have this piece here is 10, then all three pieces out to the side are going to be 10. What's important to note here is, like we said, we're going straight out, so we're going to have those perpendicular line markings in the picture as well. So the angle bisectors form in the middle of the triangle at the incenter. The incenter then is the same distance away from all three sides. So when we're looking at this, the types of things you're going to be expected to know. Given a picture, what type of center is being illustrated? So is it a circumcenter, is it an incenter, or one of the two we're going to introduce here in a little bit? And so then you also need to know what's special about that. So in this example here, it says name the center. So name the center, or they'll say name the point of concurrency. Well, so what they're talking about is this point in the middle. Point N, we want to know what type of center is that. So I've got either perpendicular bisectors or I've got angle bisectors. Those are the only two things we've talked about so far. So if I look at the picture, now I see these perpendicular markings. Okay, so I see those right away, and so the inclination would be, okay, perpendicular bisectors. But if I look closely, this line from N to E is perpendicular to the outside, but if I look at BE versus EC, we can clearly see that those two pieces are not going to be the same. So this N to E is not bisecting side BC. So when I'm looking at these, I got to be really careful that I don't just assume it's going to be one of those, a perpendicular bisector necessarily. It's got to cut all the sides in half if that were the case. Now, the other thing I noticed in the picture then is that each corner of my triangle, I see that the angles are being cut in half. Angle A was cut in half in the bottom left, angle B was cut in half at the top, angle C was cut in half in the bottom right. So that means I have angle bisectors in the picture, which means point N is an incenter. So the first part of the question, what type of center is it? It's an incenter. So then the next thing, if it's an incenter, that means N out to E is the exact same as N out to D is the exact same as N out to F. Now you got to be careful here because there's a third line or a fourth line right here. N to G is nothing. It's not straight out from N to the side. It's not perpendicular, so we ignore that altogether. We don't even worry about NG. So then in the problem it says NE has a length of 5. So this piece right here is 5. That means all three of these pieces would be 5. And so when they ask for the length of ND, it would be 5 just like NE. So this is an incenter because it was angle bisectors. It's the same distance from all the sides. The next thing, we have to do a quick definition before we can get to the next type of center. And so the median of a triangle, so we're talking a median here. So in a triangle, if I have a line that starts at a corner and goes across the triangle and cuts the triangle in half there, or that side in half. So it started at the corner and went across and cut the side in half. Now it's not perpendicular. There's no marking for perpendicular bisector here. It just comes across and cuts the side in half. That's called a median. Now what's special about the median, and again, this is what you have to kind of start equating here, when I put all three medians in the picture. So notice from point B, I come across and I cut line AC in half. And then from point A, I came across to E and I cut BC in half. And then I come across from C all the way across to D and I cut that side in half. So when I see all the sides being cut in half like that, what we're looking at then is what we call a centroid. So three medians create what we call the centroid. So that would be point P right here in the middle. Okay, so a median starts in a corner, cuts the opposite side in half. When I put all three medians in at once, they all meet at a point of concurrency called the centroid. Now what's special about the centroid? because so far all of my centers have had something. The circumcenter was the same distance from each corner. The incenter was the same distance from each side. Now the centroid, I want you to I'm going to amend this. I don't want you to worry about this statement down here, because 2/3 is just kind of a weird fraction that we don't need to be worrying about. What I want you to understand for the centroid is that when I create a centroid, so here we're at point P, the median is going to be cut into two pieces. So for instance, this one that I'm going to highlight here in purple to start with, B to F is a median. It cuts AC in half. Now notice when I put the other medians in, so when I create this point P here, I cut that segment up into two pieces. So I've got B to P and I've got P to F. So I want to focus just on those two pieces here right now. So when I'm looking at that median, so I got rid of the labels there because I'm going to do something a little bit different here. B to P. So when I go from the corner to the centroid, so B to P in this case, is considered the big part of the median. So I got two parts. There's going to be a big part that I highlighted in pink, and then there's going to be a little part that I'm going to highlight here in green, so out to the side. So every median, when it gets cut like this by that centroid, it gets cut into a big and a small piece. Now what I want you to remember is the small piece is always half the size of the big piece. So whatever this little piece here, P to F, is in green, it's always half the size as the big, which means the big is twice as big. So whatever the small is, the big is going to be twice as big. So there's my two parts of the triangle, or the two parts of the median. Now what that also means then is if I were to put those together, the entire length, so if I were to go from B all the way to F, is 3 times as big as the small. So when we're looking at the centroid, what I want you to understand is with the small piece, I'm going to take it and double it to get the big piece, or I'm going to take the small piece and I'm going to triple it to make the entire length. So that's the relationship I want you to think about. From the small, I have to be twice as big to get to the big, and I have to be 3 times as big to get to the whole thing. And again, from the corner to the centroid is the big, from the centroid to the side is the small. So if we look at what that means here, because it makes a little more sense sometimes if we talk numbers. With this centroid here, so they're telling us point Q right here in the middle is a centroid. They have SQ with a length of 8, and they've labeled that in the picture. They want us to find the entire length of the median as well as the little piece from Q to W. So what we learned on that last part here, this from the corner to the centroid is the big piece. That means Q to W would be the little piece or the small piece. And so what we talked about on that last slide was the big is twice as big as the little. So if S to Q has a length of 8, Q to W would be half of that and be a total length of 4. So QW has a length of 4. Now from there, I can find SW, the whole length, a couple different ways. Since I know the big and the small, I can add them together. 8 plus 4 is 12. Or the little piece, I can take and multiply by 3 to find the entire length. So if I take 4 times 3, SW is going to have a total length of 12. Now with these types of problems, they're going to give you different information each time. So what they told us in that case was the big piece was 8. And so that made the little piece was 4. What they might do also is they might take this picture and they might say, okay, well, Q to V has a length of 5. What's the rest? Well, so I have the little piece because I'm going from Q out to the side. So this is my little piece. That means the big piece is twice the size. So R to Q would be 10. That means the whole thing from R to V would be 15. If they give us the entire length. So if I take this information out, and let's say instead this time we talk about this median here. Let's say they say U to T has a total length of 18. So U to T has a total length of 18. Well, so if I'm looking at that picture, if the total length is 18, I know that the small piece, so if I go out to the side here from Q, the small piece is a third of that. So if I take 18 and divide it by 3, U to Q is going to be 6. And then if I know what the small side is, I can double it, and I get the big side 12. So either way I go, I can find those missing pieces of the median using those results. The small piece is always half the size of the big, and it's always a third the size of the entire thing. Last quick thing here, altitudes. When we talk about an altitude, a lot of times kids equate that to the height of the triangle. So an altitude is simply a line from a corner, so from a vertex, that's perpendicular to the opposite side. So starting at point Q here, I come directly across the triangle and I'm perpendicular to that opposite side. So we're talking about an altitude there. Now altitudes can be a little bit tricky as I go to this next slide here because they're not always inside the triangle. So in this first example over here, point Q came straight down to PR and it made that perpendicular line there. But if we have an obtuse angle or triangle, so right here I have this obtuse angle P. Well, if I start at point Q, there's no way to go across to PR inside the triangle and get a perpendicular line. There's just no possible way to do it. So what I have to understand here is when I go to point Q, we go directly across perpendicular to that third side. So this time we have to extend PR out here. And we're going to create that altitude on the outside of the triangle. So that's one thing you want to kind of keep in mind here. These altitudes can go on the outside depending on the triangle. But we're looking for that right angle coming from the corner. Now when I have altitudes, just like with our other three examples, we create a center, in this case called the orthocenter. And so the orthocenter goes with altitudes. That's the relationship I want you to remember. And so when I have the altitude from C to E, I have the altitude from B to D, and I have the altitude from A to F. When those three pieces are put together, they form that orthocenter within the triangle. Now, as far as orthocenters are concerned, there's really nothing special. The centroid had a specific relationship. The incenter and the circumcenter had relationships. The orthocenter is just something we need to be able to identify. So altitudes and orthocenter always go together. So with that, you should be able to work on or complete the worksheet that you got in class or off of Google Classroom. Again, make sure you check the answer key when that becomes available. Make sure you ask questions in class or email if you have anything specific that you need clarified.